snow. For those of you who made the ball of snow. And I will share some videos of the people that they share the videos with me so that you can see that it worked. You get your ball of snow, you compact it really well, and then you put a flame. The flame can come either from a candle or a butane lighter, whatever you want to use. You're still gonna have, the candle is got a hydrocarbon, but I don't know, it's a mixture of hydrocarbons. The butane lighter will be easier because butane is C4H what?
10.
Yes. Times 2 plus 2. Plus, what else is it gonna add in order for this combustion? Oxygen. How much oxygen is in the air?
A lot.
21% is oxygen. Most of it is nitrogen, right?
Yep.
And then you make carbon dioxide and water. If it is in the right ratio, the right ratio is 4 carbons, then 10 hydrogens, then you have 13 oxygens. Double it all up in order to get rid of the fractional coefficient. And if you have 2 moles of butane and 30 moles of oxygen very close together right there, those are going to combust and they're going to make this. The chances of that happening with just the 21% oxygen, or if you are exhaling, you inhale 21, exhale 16, right? It's not likely that you're going to get complete combustion. Just not going to happen. So what are you going to have? You're going to create some soot, which are the products of incomplete combustion. This is the product, which is what we always do. In chemistry, we assume complete combustion. That doesn't happen. That will happen if you actually put pure oxygen in there. Or like the paper, remember when I had that paper that burned completely? It's because it had extra oxygen. So what? I burned the paper, everything disappeared. Remember that? We did it at the beginning of the year. So you're gonna have the products of incomplete combustion. Does it smell like burn? Yeah, you are burning a whole bunch of stuff that is in there. There are other things in there because your butane is not just butane. Well, actually the butane is just butane. But if you have the candle, for example, you're gonna have other things in there that that may be forming it as a part of that soot. So does that make sense? And it does smell plasticky, and it does burn, and you do see that black thing in the bottom. It doesn't, it will melt, but water has a high heat capacity, so it absorbs heat before it starts melting. It takes a little while for it to start melting. Is that what you also, I forget who turned it in. But hopefully that's what you saw. The other one that I think was cool is, and I don't know if anybody did it, or I forget. I know somebody did both of them. So if you actually had a cup and you put a snow, which was easy, you just grab a cup and you put a snow in the cup, and then you take the cup and put it in the microwave. Then there were some kids that said that the water was dirty. And I'm like, oh, it's kind of like the still water, why would it be dirty? I know it has a few things, but as far as dirty, I wasn't sure. So I did it and I wanted you all to do it. And what happens is, when water evaporates, it goes up and it makes clouds, right? Everybody knows that. That water that evaporates doesn't have any salt, doesn't have anything in it. It's really just evaporated water. It's actually very, very clean. However, this part I did not know. I'll tell you the part I know and the part I didn't know. The part I didn't know is that wind is crazy good, and wind, not a whole bunch, but can get up there a few bacteria. There's a bacteria that lives well in that really freezing weather. Not weather, but freezing temperatures, right? And not just that, but the wind also brings in some sugars. So not only you have the bacteria, but you also have the sugars that are there. Does it happen all the place, everywhere, and is it consistent? No, this is random, right? Sometimes it happens, and when it does, you will have the bacteria and you will have those sugars up there, and it will be bacteria, and the bacteria will rain. Now, when the water is falling, the water may mix with CO2, right? There's carbon dioxide gas. It may also mix, because in fossil fuels you have some nitrous gases and you have some sulfate gases, some sulfur gases, and when they mix with water, what do they make? Carbon dioxide and water makes what?
Carbonic acid.
Yes. So carbon dioxide and water make H₂CO₃. Sulfur dioxide and water make H₂SO₄. Can you believe that?
Yeah.
Can you believe that acid rain has sulfuric acid in it? Sulfuric acid is a strong acid, right? What do you think these acids do when they fall?
Kill people?
No.
Oh.
They don't kill us, they're not concentrated enough.
They kill planets.
Not either. They weather structures like the pyramids and the statues. Remember that if you have an eggshell, the acid will erode the eggshell, right?
Yeah.
Well, so they erode, and they call that weathering, you know? They weather things. So if you go to the pyramids, you see that they have been weathered. It's not super concentrated, it's not humongous, but especially if you live in an area where you have a lot of carbon dioxide made by cars, right? A lot of population, a place like New York, a place where there are a lot of factories and you're making a lot of these things, the rain will have more, it will be more acidic. And you can test the pH of that rain. I knew this part. What I didn't know was about this wind. And talking to Dr. Wicker, he used to live in Houston, and he said, Janet, sometimes you go out in Houston, I didn't know this either. I heard about it, but I've never seen it, and I didn't think it was as real. He says, some days you go in Houston, and you see that the day is kind of foggy, but it's a different type of fog, and it is not fog, it's sand from the Sahara Desert. Did you know that? Right? It was in the news a few years back, but yeah, the wind is crazy, can make sand travel all the way from the Sahara Desert, and it has nutrients and stuff that come in here, come to Houston. So sometimes wind can just keep going and goes, and boom, it makes it all across the ocean, and it comes over here. That's crazy. So if that can happen, and we can see fog, not fog, but we can see those days, definitely that's happening, and we can see that bacteria. That I saw a reputable video, I don't know if I sent it to all of you, that tells you that can happen as well. Do people eat snow all the time? Do they get killed? No. The chances of you getting a whole bunch of bacteria is probably small, but they always recommend with rainwater and with snow that you boil it, because boiling will kill the bacteria. There is nothing that stands out to boiling that I know. Or sodium hypochlorite. What is sodium hypochlorite? Bleach. So those two things tend to kill just about everything, right? So it's important to know this, because some of the answers I got, I gave this to all my classes, so I don't even know who got it, because I sent it to all engineering, AP, and honors. And some people are like Miss Thompson, everybody knows that it's the no falls, it's gonna be dirty because the ground is dirty, and I'm like, that's not what I'm talking about. The other thing that I did learn is that the first snow that falls actually scrubs the air a little bit. It reacts, so some of you have put it, it reacts with some of these things and it scrubs it. So the first snow that falls is the dirtiest one. Not because it's touching the ground, obviously that will make it dirtier, but because it's the one that gets all the stuff out there already. Now, once the first snow falls, it gets rid of a bunch of this stuff, and the later snows that fall have less of this, at least the acid part of it, right? And some of the scrubbing that they did as it fell down. So if you're gonna eat any snow, don't eat for the beginning, you eat from on the top. There may be dust and other pollutants that fall as well, and I know Caroline Watson was able to see a few little black spots in there. It's like a little dirt in there. You know, wherever she got it from, she did get it from the top. She's Miss Thompson, I did see something. She's the only student that saw anything. That tells me it doesn't happen very often. Between all the classes, how many students did it, right? Does this make sense? So this is real life. The other one that we did had to do with ice, not ice, snow. But snow, and I told some people, I don't know, again, I gave it to everybody, so I'm not sure who I told what or when, but they were supposed to put salt, vinegar, whatever you found at home, sugar, whatever, cookies, whatever you wanted to put in there, and see, put it in several cups, and see what cup was going to melt the snow the fastest. And everybody that answered this question said sodium chloride is what happened, is the one that did it. You also had baking soda, and you had sugar. No, that's glucose. See, Ali, I forgot the name for sugar. 12F22O11. I think it's 122211. Sucrose.
No, it's 23, I think.
Google it. I'll Google it.
That's right.
That's right?
It's 12/22.
Okay, 122211. Okay, and then some people put vinegar and they put a few other things, but everybody agrees that it was sodium chloride. These two, what do they have in common? Jacob, what do these two have in common? Sodium. Sodium is a part, and they're both salts, ionic salts, right? They're both divided, so they are both gonna behave very similarly. So why will that one be better than this one? They're both gonna divide. They have NaAA or SNAP, whatever you wanna call it, right? So we know they're gonna divide. Not all salts are going to dissociate, but we know the ones that have SNAP will dissociate. So these ones, and this is interesting, in these ones you have, when you put the sodium chloride in there, and I'm only gonna put the chloride, just not, well, maybe I'll put them both. You're gonna put the Cl- and the Na+, the little tiny Na+. They have a humongous affinity for water. So what is the water going to do? It's gonna be crazy attracted. The positive side is gonna be crazy attracted to the chlorine, and because it's unimaginable numbers with this humongous attraction, they're gonna dismember the sodium chloride. They're gonna go chunk. They're gonna get it, and they're gonna be so attracted to it that the chloride is eventually just gonna pop out. And the negative sides have such affinity to the sodium that they're going to remove it as well. So they start picking at it one at a time, right? And start dissociating this. Now, we haven't talked about equilibrium, but what happens in here is that you always have also a little layer of water that is in this surface, right? You have that water, and because you are below zero or at 0 degrees, you will always have, in that moment, you're always gonna have some of the water trying to freeze and some of the water trying to melt. So it's an equilibrium. There's always gonna be a little bit freezing and melting at the same time. So when people say that you lower the freezing point, what happens is, in order for ice to be formed, you have to have a perfect crystalline structure. gotta be a perfect crystalline structure. It's got different shapes. You have to have that with all your hydrogen bonds in here. It has to create these crystalline structures. Well, what do the sodium and the chloride ions do? They get in the way. These are called negative properties. They get in the way. So they created the hydrated shells when the sodium and the chloride went in the little water that was on top. But when the water wants to go back and turn into ice, it's not gonna be able to, because it's got things that won't let it. It's like I'm trying to become ice, but I have something right here that won't let me become ice. So most of it is going to, a lot more is going to melt than what is going to refreeze. Does that make sense? So it's about getting in the way. And this is when I talked about how we can have cryogenics. What is cryogenics? When they try to freeze people's bodies and heads, they put something, it's actually more like a sugar, that they put it in your blood so that it gets in the way. So that because when water freezes, it expands, right? And it can pop a Coke, it can pop anything. The expansion, I had a pipe and it expanded, it broke the pipe. It will break the most unimaginable things. It's very, very strong. Water is going to be denser and denser. The colder it gets, the denser water gets, the closer it gets. At about 4 degrees C, it starts making those bonds, and the water starts going like, and it starts making those crystals, right? And when it does this, it expands, it becomes less dense, and it forms the crystal. Well, it cannot form a crystal if there is stuff in the way. It can't. Actually, the salt water in the oceans, the Arctic and the Antarctic, you know how they have those big glaciers or those big, those big old icebergs, right? They extrude the salt in order to be able to be formed.